and I'll just start stepping through some things. So the recording is on. We're being recorded. This is the lecture for Design 350. It's Tuesday, November 3rd. It's election day. Hopefully, you are happy with the election results when they're done, whatever those may be. We're going to jump over now. We've been doing our surveys all based on an XYZ coordinate system where everything's measured horizontally, east-west, and north-south, and away from the earth, up-down elevation. And we're just taking straight measurements to get those. So now we're going to use a different type. Hi, Michelle. We're going to use a decimal degree and a distance to locate things. And we do that because that's how a survey transit level works, right? You plop it down somewhere, and then it pivots around on its point and takes dimensions. And we're going to go into that more on Thursday. I'll have some images and some photos and some videos to help you understand a little bit more, but we're going to do it based just in AutoCAD today so that you start getting an idea of it. All right, so that's what we're going to be working on. This module is due on Sunday. It's a little bit, we're not really going to dive into this section deep. If you're interested in it and want to get good at it, which if you're going to be doing landscape or any type of residential or even commercial architecture, you're going to need to know some of this. You might want to use one of the optional modules. But what we're going to do today is we're going to take a survey record that was made by a transit level or site method. A transit is a piece of equipment. Okay, but we're going to take a halfway step today. We're not going to do the whole kit and caboodle, the whole shebang, the whole 9 yards. We're going to take a halfway step, and we're going to put an instrument someplace where we know it's an XY bank. I've stuck it in, and then we're going to take a distance and a bearing to each ground point where a rod would be placed. That positions it. It still isn't going to give us elevation. We're going to do that on Thursday. So we're going to do our boundary points only and not the elevations. Okay? And now when you're done drawing it, I'm going to give you the survey record. When you're done drawing it, it should overlay almost exactly over the previous boundaries that you've drawn. And I'm going to show you how to, or actually I've got a little video that shows you how to do that comparison. So here's the survey record we're going to use. Okay, and here's an empty transit level record that you can use on Thursday. And I want to make sure that you guys know how to set up your workspace. A few people were having trouble with their dynamic input being on, and their XY doesn't work the same as my description. If your dynamic input is on, it works the opposite. Okay, so some people were having some difficulties with that. So you need to have your workspace set up so the dynamic input is off. And here's a video on how to do it. I'm not going to explain it during lecture. You should be able to just watch a short video and be able to do it. So that's the new material we're going to go over today, but let's take a look ahead a little bit also. Next week, okay, we're going to start working on your optional modules. So I want to talk about it a little bit. Is that in Revit? No, that's Benjamin asks, is that dynamic input stuff in Revit? No, that's for when you're working in AutoCAD. So if you're doing your work in AutoCAD, it makes a difference. So that's a good question. So next week, we're going to start optional modules. There's been a couple of questions about that. We'll probably have time for 2 optional modules and then a bunch of review, maybe 3. But this is week 10, and there's a total of 16 weeks. And so really, and one of those weeks has Thanksgiving in it, which generally, although this year maybe not quite so much, generally people need a break during the Thanksgiving week. And so we'll take a look and see how that goes. All right. But probably 2. So starting next week, start work on your optional module work, and I will adjust the grading to make it appropriate. Essentially, every module you do is worth 4 points, and your grade points are just based on the average of those. Even though it says I add them all up, it works out to be the average. So if you look at the module description of assignments for optional modules, you'll choose 2. You'll get 2 weeks to do each one. And this week you should preview the choices so that you can make your choice and get started right away. Now, if you see some of that work in there and you go, well, what I really want to do is, and you pitch it to me, you can do that. But you have to make a regular proposal with a good pitch, and it's got to be well thought out. So this is the week for you to be looking at that and pondering and thinking. I know that's a lot on top of this new work, but this is a 5-unit class, and so that's just the way it goes. I expect it. That's the tough life of having a high unit class. So the idea is that you're going to work on stuff that you already know. Now, if you want to get better, for instance, at this survey work and actually maybe pitch surveying a site to me if you have some measurement equipment. And your measurement equipment can be anything. It can be lengths of chain. People have done it forever. It can be a wheelie thing. It can be a laser. It can be a rod. You can walk it off. You can use a water level. I can show you how to do a water level. Yeah, yeah, that's Benjamin's going, yeah, the pain of high unit classes. Man, what a booger. But if you want to get levels using water in a tube, it's very simple and it is precise. It is excellent. And people have been doing water levels for about 3,000 or 4,000 years. So we're pretty good at it by now. So that's there, but be careful in your choice. Okay, this is big. Some people go, I'm going to do this thing and it's going to be so cool. And no. Choose a project that you think you know how to do. Okay, take it easy. Don't get excited. Do something that looks like you can pound through it and just show your skill. And develop fluency at your skill. That's what I'm hoping. It's not aspiring goals. Okay, this is not the time to go, and I'm going to survey the moon because I have a drone. We've got the NASA thing and I can do a land planning thing on the moon and it's going to be so cool. No. Make it something that you can do. That's really important, actually. It's far better to do a very nice job of something that you can do. And as you're going, I might add some feature requirements or suggestions to it. But you want this to be a chance to show off and demonstrate what you can do while stretching just a little bit. So let's take a look and see what some of those might be. Let me see here if I can find one. Hold on a sec. Well, that's kind of weird. Why are you doing it from Canvas? Hold on a sec. There we go. Just got an email from somebody that says Canvas won't let him in. Don't know about that. Anyway, let's take a look at this, and I'm going to put this up here for you. And I'm going to go to the modules, and we're just going to talk about them briefly as we go. So turn that off. Here they are right here. And let me make it a little bit bigger. So now you can take some of these and break it up too. For instance, there's a SACOG proposal, which you learned a little bit about SACOG. Here's a template for it. And you would take one of these topics and make a presentation to your planning area to include in a SACOG proposal for your city or your neighborhood. For instance, if you knew that the area was really interested in beefing up its communications capabilities, you could talk about how you could, with your property and maybe 2 or 3 others, put up a nice communications infrastructure of 5G or energy. You could put up some EV charging stations based on solar cells in your area, but they would all be based on using the area around Arden where your property is, and of course, if possible, using that property. So there's all sorts of things you could do. You can work on food. Food is big because you can make a garden. You can make one of those. I was talking with Natalia, and the state has just okayed in the health code the ability, if you want to sell food out of your house and you do something like less than 25, I don't know what the number is, but less than 25 meals per day, you're allowed to do it. Yes. So Benjamin asks, can you use a different location such as Del Paso Heights? And the answer is yes. The only thing is you've got to do a little bit more work because you'll need to you'll need to make the site plan and do a little bit of extra work on that area, but it should be fairly simple. You don't have to do all of the calculations and everything for it. But the food thing is pretty cool, and there's even apps that tell you how many servings they have left at this place, where you can just go to a local home in your area and pick up a very nice home prepared dinner, but it follows certain rules. So food is a big deal, shelter is all of these have things, and the idea is that you can tie in some of the work and some of the information that you got during our seminars. All of these are very applicable to really addressing fair housing issues in our area with a plan that includes the lot that you're going to be on. But SACOG is a little bit bigger than just the thing that we want. Here's a template. So there's an example one. Here's a financial analysis for a market cap and seeing if you can put it in the CC&Rs. This one's really tough. This is really getting the data and doing an appropriate analysis. So if you've done Design 310, this would be really excellent. It's looking up some lending information, some calculations on median income, making income versus loan limit tables and expanding that table to affordability of certain size houses, because it doesn't do any good to make a building if people can't afford it. And if the banks, we always get back to the banks. It's kind of like you do all these regulations, these good ideas, and the banks say, I'm not going to loan you that. You don't make enough. And then how can you describe the CC&R so this is sustainable while still allowing the owner to generate wealth? There's the problem right there. How do you do this in a fair way that lets the owner still generate wealth? So if you say, well, I'm just going to cap this price so it can only go up 2% per year, and everybody around this place is going up 4 or 5 or 6% per year, that's kind of a ripoff for that person. So it's like, yeah, well, you got into this place, but we're going to make it so that you can't generate generational wealth. So this is a very, very tough one, but very, very cool from the Fair Housing Initiative. And there is no right or wrong on this. This is just data and using it in a good manner. Okay, so the next one is that sanitary drain design data. So it's like, where do you get it? Okay, identify what regional sanitation web-based resources there are, and there are some. There's a sizing calculation site that's pages and pages long, submittal requirements site, approval of alternate technologies, small development technical support site. So there's all these, and then there's identify the sources needed to determine the existing connection size and the ability to increase. So this one is really cool, and it bears directly on what Dr. Hernandez was talking about. And I checked it out. The information is there, but it's not one of those things where you just go to Wikipedia, Bing, and get it. You've got some work to do on this one, but this would be super, super useful work. Community use of property proposal. Still required to allocate 4 lots. But you're going to allocate at least 1,600 square feet to community use. Now, you'll have to specify what that means and the scope. Who can use it? The owners and neighbors, the public. Who gets to use this 1,600 square feet? And there's models for this, by the way. You can just look it up. There's models for this all over the place. And how can that be made sustainable so that it's not just now? And does it generate income? You got a community space. It costs money. And so how do you do that and add that to your layout? Another way to go. Accessory building infill proposal is to reimagine this plan that you've had so that each lot can support an accessory building. Now, an accessory building can be a granny flat. So Benjamin asks, would that be a good one for community gardens? Yes, that would be an ideal application of community gardens. And how would that work? Who gets to use it? When do you get to use it? Who does the fertilizer? Who pays for the water? Do you need to protect the stuff from people just walking up and getting stuff? So those would be all parts of those plans. And that would actually fit in the community use very well. Accessory buildings can be a granny flat. It can be an office. It can be a kitchen for an outdoor barbecue area for cooking for the community that you're going to sell on one of these new things. It can be a storage facility. It can be a workshop. Accessory buildings can be a lot of things. I'm suggesting it be like 300 to 350 square feet. But prepare a financial analysis. How much will it cost? What can you rent it for? What are the maintenance costs? Do it with knowledge. It's not, once it's done, do you have to build it right away? Do you build part of it now? How about the infrastructure? Where's the electrical going to come from? Where's the water? Where's all that going to come from? If nothing's done at this time. So this is all kind of extra additional stuff that addresses those fair housing applications with a plan rather than just saying, yeah, and we're gonna. There's so many was gonnas around that don't gonna, that we want to gonna. We want to make sure it can be done. Here's a winding up landscape plan. Just give us a good landscape plan for the entire little subdivision. And then how would that work? Okay, how does that work into the sustainability and the water costs and who's going to mow and blow? Does it go into the CCNRs or not? This is a really, really, really good one to actually put together a real landscape plan. And of course, you've only got 2 weeks, and if you want to extend it to 4, that's good. But this could be a big project, so you have to do it within the scope of what you know that you can do. And then use of survey tools, drones. If somebody, I'll pop that one in there, but this you'll get to use our drone simulator, learn how to fly a drone, learn how to take pictures and put those together into a topo, and then we'll give you some stuff to work with to get survey data, drone survey data, and do some lot planning with it. And then use of survey tools, distance and bearings. So this is where we'll follow on from what we do this week, and I'll give you much more information, and you can use something as simple as a stadia or a wheelie thing, and you have to have a little bit of information. If at the minimum, you have to have a compass, and we'll get you actually surveying a site. And then if somebody wants to do a commercial site development proposal, let me know. I have one available. It's very much like doing the Winding Oaks, but it has light commercial on it also. So you have to do parking lot design, layout of your building. And that's all kind of problematic right now because, every place is going empty. So what will that commercial site look like? Will it be work live? Will it be restaurants? Will it be small studios? What will that look like? Okay, and then if you're interested in the Minecraft construction simulation, that is starting in my Design 300, and you can join in with that. I can show you, let me see if I can show you. I just blew that. I went to the wrong spot. Let's see if that's where it is. Yep, here it is. Nope, that's the wrong one. I'm in the wrong spot. Let me go get into that better. Sorry about this. I need to. Oh, I know where to go. I can get it from here. I guess that's just all its own thing. So you're going to go to a plains biome and teleport to this site that you're seeing right here. And shoot, hold on a sec. Nope, that's not what I got too much stuff open all at once, guys. Okay, so you're going to go to this biome right here. And you're going to teleport to this site in the biome, and then you're going to do a development on that site, which essentially looks like this. Okay, so that's what your site looks like, and you're going to put on a concrete pad at a certain elevation, and you're going to excavate. And so you're going to have to actually draw this site, make the map for it, make your stormwater pollution prevention plan because there's water all around it. So, and then put it in. But mostly you're going to be doing the drawings that go with this, and then probably take you 2 or 3 hours to actually go do it after you've got the drawings done. Okay, so you've got a drawing site, you've got photos of the site, you can walk the site, you can see what's nearby, you've got some demolition to do. You can see that the site goes from here to here to here to here. So you have some demolition to do, you have some excavation to do, you have some infill to do, you've got a concrete pad, and you've got some water nearby, and there's water right over here. So you've got some serious stormwater pollution planning prevention. You've got some utilities. There's actually there's a small town right over here. So you have to be able to run your utility lines, or figure out that septic will fit on this site. I think that septic will fit over here if you put the septic in. So it's kind of a cool site, and you get some chance to do stuff. So if you're interested in that, you can do that. So those are the things that we've got. Cool? Yeah. Yep. Okay. Yeah, so this would actually be a good one to start out with, because what you're going to see is everything is based on XYZ coordinates in Minecraft. And so as you calculate your positions in Minecraft, it does the calculations. And then we also have an Excel spreadsheet where you can basically draw in Excel, basically color out the squares in Excel that match up what you're doing. And then we use the Excel calculator to do it visually. So it works both ways, right? Um, the nice thing about the Minecraft is you can walk the site. Well, you can actually walk your site because you already own it, right? Or somebody can walk it. So we can go over that a little bit, but this Minecraft simulation is really kind of cool. And then there's a program called FME that goes back and forth from Minecraft to AutoCAD. And so you can start looking at that too. So we'll go over that all. We'll check that out. All right. So that's a good one to think about. Okay, so that's a little bit of a preview that you can be thinking of. You can send me some emails. You can meet during office hours, and we can discuss some of that and how it would work. And you can try it out and just see. You can even look at different ones and try them out to see what you're interested in. So that's really there to let you sort of work in the realm that you're most interested in. But for right now, then, let's go back and take a look and see what the survey record looks like right now. So, and hopefully you've watched these. This makes a lot more sense. I post these things on Sunday or Monday with the purpose that you've watched them so that the lecture makes more sense. So if it doesn't make much sense, I'm sorry about that, but there's a little bit of pre-knowledge that I'm hoping that you've got. But we have an instrument that's at a certain spot, and we're recording distance and bearing, but we're using angle because that's what it looks like. And here's what it looks like. Okay? The survey record now has something called backsight, which we're ignoring right now. That's telling us where our instrument is. And let me just show you. That's what a survey transit level looks like. Okay? And you can see it sits on a tripod. Let's just make it big. It sits on a tripod and it spins. And it's perfectly level. It's as level as you can possibly get. The little bubble on it is incredibly precise. And these angles are incredibly precise. And you look in one end and you see through the other and you magnify the rod that's sitting on the ground far away, and that lets you know what's going on. So you plonk this thing down in one spot, and since it takes so long to get done, you need to know where it is and everything, you just move the rod around. Okay? So that's what each of these are. They're rod readings. This was my first rod, and then I moved my rod, and I moved my, and I made a mistake here on purpose. You guys can't just copy mine. If you do, that's a boo-boo. Okay, you have to put your own drawing in here. Okay, so I have points 1 through 15. Now, I will say that I took this data from somebody, okay, and laid it out. So this data may or may not be perfect according to yours, but it'll probably be pretty close. And what you see is most survey instruments go clockwise as they read the angles. So this would be 0, 90, 180, 270. And AutoCAD defaults opposite of that. So I have to show you how to fix that. That's in the video. And we've got it set up so that it's like AutoCAD. I'm pretending that I adjusted my instrument so that 0 was facing perfectly east. Now, if you get into the optional module, that's really hard to do. And so I'll show you how to take reference points using a compass and 2 points and actually find out where it's facing. And you can move this line in AutoCAD. But for now, we're going to pretend that that instrument was facing perfectly east. In the game that we're going to have on Thursday, that's how it's set up. And that as I twist, it's sitting right there. And as I look out at the first point, it's twisted through an angle. And I see the point. Okay? And I record the angle from my machine and the distance from my point to the rod. So let's see what that looks like on my Jamboard. Okay. I set up my instrument and I set it up perfectly east, and then I twist it so that it's pointing right to my first point, and I read the angle and I note the distance. Now there's lots of ways to get that distance. You can use a tape, you can use a chain, you can use a laser, you can use a stadia. There's also, you can use, they're getting some little handheld GPS device, not GPS, accelerometers that are very fine that can actually measure as you're walking. They have incredible math in them, and they feel the acceleration of your walking as you're moving across the earth. So they have all sorts of cool ways, but the idea is you got your machine sitting right here, and you look through it until you can see the rod, and then you focus it, and you read the angle and the length. And on Thursday, we'll read the elevation, but we're just reading the angle and the length. And then your rodster will go, okay, you got it? Yep. And then they'll go to the next one, and you'll be at 1.02, and you'll plunk the rod down, and you'll read the new length and the new angle, so on and so forth, each time. Okay? Until eventually you get this. So every time you read a length and you read an angle. And we're using clockwise as the plus direction. And it is so important that you put that on your survey record, because you have to set up your drawing field to make it that way. Okay, so one more time. You always set where east is first. You actually, that's what we're doing. In reality, you don't have to set it up in a specific way. But then you have to do some recording, and it's what they call a back sight. And this was a back sight to 1 point. But if you don't know the angle that your 0 degree is setting at, you have to do a back sight to 2 points, so you can use the align command in AutoCAD to reposition your drawing to the true world as measured. So we're skipping that right now, because that's a whole bunch of stuff that we don't want to deal with until we know how to draw. So at this point, what we're saying is we have amazingly set up our instrument and calibrated 0 degrees on our instrument to be pointing due east. And there are instruments that allow you to do that. It's called a total station. And there are a few even more expensive transit levels than what we've got. Our transit levels are about 15 years old, and they cost about $10,000 15 years ago. Probably about the same now. A really, an even higher quality one, and not quality, but one with more features where you can adjust your 0 point. It's probably about $15,000 to $20,000. And a total station, which does all of this electronically, is about $30,000. Okay, and a total station is like a sight, but it's got this cool concept in it where you can flip it automatically, and it eliminates the reading error built into the machine. Because no matter how good your machine is, there is error. You just can't get away from it. And the farther away your rod is, the more error there's going to be. That's just life. And so you can eliminate a lot of that error with something called a total station. Okay? Mostly, none of you will ever need the precision of a total station. You'll have to understand that it's there. But when we're working on even a large commercial lot that's maybe, 200 or 300 yards long, that's not a long way for a transit level. Okay? So Mostly you won't need it. But there you go. We're going to draw, we're going to pretend that 0 has been set up to be facing perfectly east. We're going to measure the angle and the distance. And then I have to know how to draw. I have to know how to put this stuff into AutoCAD to get this boundary line. So let's take a look at AutoCAD. Here it is. Here's my AutoCAD drawing that I took that from. Here's my model that I drew. But look, here's how I get going. Now, I can draw this anywhere. I can draw it anywhere on my sheet. And then I can move it so that this point, that's my instrument, is lined up with this point that I've identified. I've said that station 1 is sitting at 263.77, 482.23 from my 0 point. So I can draw this anywhere and then move it so that the center is on this spot. So here's my data. I copied my data in. Okay. And I see that this is my angle and this is my distance, angle, distance. And I did a few points. I did the first one. So if I measure that angle, it should be 58.91. I know I can do that somewhere. Annotate angular from here to here. And I have to type in units. And I have it at 59 degrees. I don't have it at 58.91. Maybe it is. Let's see. It's showing that it should tell me in 2 decimal places. Let me take a look and see if that will. Primary units, 2. There it is, 58.91 degrees. So that's my first one. I went 58.91 degrees and then 399 feet. And my second one. So let's see here's where I'm going to type my commands so you can be watching up there. I'm going to do the third one now. It's 69.06 at 428.67 units. So I'm going to draw a line. Now notice dynamic input is off. It's off. I had to set it over here, dynamic input, and then turn it off. Okay, so draw a line from my first point, which is the center of the circle. And then I type the distance, 428.67. Then the angle sign, it's right above the apostrophe, 69.06. Oh, I forgot the at symbol. See, it's terrible. Okay, it's from where I'm at. That's like, I got to do it all right. 428.67 at an angle 69.06. And that end point is my next point. Now I can get my next one. from my endpoint, from where I'm at, for 12.51 at an angle of 103.95. Let's just see. I'm going to check this out. Oh, look at that. I think that's pretty good. Remember that was kind of straight at the bottom? Look at that. I think these numbers are pretty good. And I can either erase these as I go so that I'm really just looking at the one I want. But that's what I'm going to do right there. Okay, now to do even better, see how these are all individual lines? If I draw individual lines, sometimes it's hard for them to show up. So I'm going to go as a polyline later on so that it's all one polyline, end to end. Okay? Yeah, auto round. It was. But it was, so Natalia says, was that auto rounding? The answer is yes, but the rounding was happening in my dim style because that's where it was reporting from. So I had to increase my decimal units in that. Now notice, for those of you who may not have watched the video, my units are set up to go clockwise. Cool. Now, since we're here, I'm going to show you this direction thing. You can actually, if you know on your compass where your zero line was from your instrument, you can actually type it in. Okay? So you can actually type where your zero is, or you can say whether it's east, north, west. You've got a lot of control over it. And that's what they're going to call, that's fine, magnetic north. And true north is always a little different. Remember that if you're reading your direction from a magnet, our magnetic field is not perfectly stable. It moves around on the Earth compared to where they take true latitude and longitude from geometrically on the Earth. So there's always a correction of true north to magnetic north, but we're not going to worry about that either. We're going to take our readings as true. We're going to take our readings as true. Okay? So that's how you get this done. And so your goal then is to take the data that I just gave you, if I can find it. I gave you a link to this data, 15 points, and run it right around. Now, it may be off a little bit. I generated this data from one of these that I picked that was in my file, and I don't remember if it was one that I had changed and made a mistake on purpose to show or not. So this may or may not match yours exactly, but I think it's going to be pretty close. Okay? So that's what you're going to do today. Now I want to show you another cool tool that's available to you. Okay? So I made a duplicate of the drawing. There's a duplicate of the drawing just to show you something. And then I made another duplicate of it. And I made a minor change. And can anybody just really quickly tell me what that minor change is? Anybody got it? Nope. That's the same. Nope. It's just That's just me zooming in and out. See, it's really hard. There are two minor mistakes in the duplicate 2-wrong file. There's two minor mistakes. And so I want with AutoCAD to nope, line type is actually the same. If I zoom in, you'll see there it is on one. There it is on the other. Good guesses. So let's see if I can find it. I can actually, if I've got my drawing open, and let's say this is the one that I want to use as my standard. It's the one I want to compare to. So I want to compare my wrong drawing to my right drawing and see what the difference is. So I'm in my right drawing. It's the one that's right. And I go to this cool little tool. It's under the A. And it's in Drawing Utilities. And there's a thing called Drawing Depth Compare. Do you guys ever just get in here and start looking at things? It's so cool. Like these audits that you can do, the drawing properties. You can do recoveries. You can purge, get unused blocks and things to make it. It's like really, that's really good if you wrote the boss is a dope and then you got rid of it, but the record is still in there, so you want to purge it. All sorts of stuff. But we're going to do this compare drawings. So it says, oh, okay, what do you want to compare to? And now I have to find it. I had it. I think it's in here. There it is. There. So I'm going to compare my duplicate to duplicate number 2 that's wrong. So you have to know where your files are. Oh, look! Is that the coolest thing? It outlines what's wrong and it shows me. Wow! And I bet you I can even find out how far it's off. It's off by 10 units, whatever a unit is. Meters, feet, inches. I don't know what my units are. Tells me how far off it is. Isn't that the coolest thing ever? You guys want to know how I'm able to grade DT100 drawings so quickly? It's like I just do a quick compare. It's really cool. Now I can also do what's called a data export, and I could actually compare these in Excel also. So that's kind of cool to see if you drew them even in the right direction. But I can import a compare object. I can save this image. I can do all sorts of cool stuff. So one of the things that you're going to want to do is get this drawing done like this and then compare the boundary that you just drew using my data to the boundary that you drew using your XY data. And they are not going to be perfectly the same. There should be, I think, some very minor differences. Maybe almost not even enough to tell. Okay? But that's your lab today. Draw using this data. You're going to get the boundary and you're going to get these lines. And then compare it to your existing boundary drawing. And I don't care which one you use as your standard. Probably your XY that you took the data of, that probably wants to be your correct right. And then you can compare this one to it. Cool? Any questions on that? Isn't that the coolest thing you ever saw? It's the coolest thing I ever saw. Okay, so if you have no questions at this point, let's take a 10-minute break. We'll come back at 10:05. That'll give you guys time to go vote. As I was saying earlier, hopefully the election comes out the way you want it. That would be great, whichever way that is for you. But do pay attention to it, and hopefully you've been able to do. How about the circle in the center? Where should it be? Okay, so the data says the circle in the center should be at x equals 263.77, y equals 482.23. So it's listed on the drawing, and you always have to have that. You always have to have the location of your instrument recorded on your file. On Thursday, we're going to talk about how to do it using a backsite. Okay, but we're not going to do that today. We're just going to use this XY because you guys are used to it. So to get that, let me just show you. If I'm going to put a circle somewhere, I just go to my home circle, and then it asks me, where's the center point? So I'll put down something 500, 722. Then there's where that is, and I don't care how big you make it, but its center is now exactly where I wanted it to be. Okay? Now, you can do this in Revit, but you have to make a whole bunch more different changes. And my suggestion would be to use AutoCAD for this. And if you get into doing the other as the optional and go farther with this, I'll show you an auto lisp routine that will actually put these lines in for you and draw the boundary for you based on that CSV from your survey. It's really, really cool. It's an auto lisp routine. I just have to go find it. I know I've got it, but I just have to go find it. Okay, so you can load very cool under Express. You can load auto lisp routines. Maybe that's not where it is. Maybe it's under Insert. Now I have to find out where they put it now. Express to add-ins, maybe. No. Now I have to find out where you put in. System list, attach external data tools. I have to figure out where to put the auto lisp routines again because they keep changing it. But it's in here somewhere, and we'll find it. But an auto lisp routine is basically one that you can create a program that will use points and draw them for you. Okay, so Laura says, by setting the units at east, yes. So on units, you want to make sure that you're set for clockwise, 2 decimal places, and that your direction is east. Yes, that is correct. And that way, and I drew this line in just as a reference for myself so that I could do measurements. Yes, you still set unit lists because I haven't told you whether this is feet, inches, or meters, or kilometers, or miles. So you don't know, so you'll leave it unitless until somebody tells you what the units are. Cool? Any other good questions? Okay, so we'll take about a 10-minute break, and then I'll be back. And we'll go over what the lab is.